This is the episode 4 of Learning Kotlin Live. Hello, can you hear me? We will start in 2 minutes. Hi there. I think that's all we got for today. Yeah. So, hi everyone, welcome back to Learning Kotlin Live, and this is the episode 4 of my live streaming. And hi everyone. So we will be talking about, this is where we left last time. We were at this almost increasing sequence, and this is implemented correctly, but we need a faster implementation for this one. So also we talked about Null safety last time, but we didn't have enough time to go through this. So let's first go through this Null safety, then we can go back to the CodeSignal game there. So yeah, we all know that in Java there are objects and primitive types. Primitive types are non-null. Like for example, an integer int is either 0, it's default to 0 rather than nothing. But for objects, there is a null. It is possible for a parameter to point to null, which means the default. You can say it's a default value, or you can also say that it's pointing to nothing. But yeah, so basically in Kotlin, Kotlin is striving to fix that when you are trying to reference a null and operate it. Like for instance, if you want to calculate the length of a null pointer, which is of type string, maybe, then you will have a null pointer exception. That's something we usually run into when we are developing in Java. And there are annotations that annotates, because Java natively does not support non-null types, not like C#. In C#, they are nullable objects and non-nullable objects. But in Java, we might use some annotation to try to mark something as nullable and others as non-nullable, with the at non-null, at nullable, and at non-null annotation. So the at here is annotation, and it would be. I'm not going to talk about this because this is a Kotlin lesson. Although I think we will eventually run into annotation in Kotlin. But for now, all I know is annotation in Java. So let's not talk about it today. So yeah, So how do we in Kotlin? Most of the maybe all of the classes are default to be non-nullable. So for example, if we're declaring a variable of type string and its name is a, and we can never set it to null, and this will be checked at compile time. So if we try to compile this, it would show an error message when you're compiling this Kotlin script. This is some JVM. Yeah, Kotlin on JVM. So to allow nulls, we need to declare a nullable object, and it makes it point to ABC at initialization too. So like with this, you can point it to null later if you want to. So it is invalid to so if you want to check for null, you can just simply do this as how we do it in Java. But there is also something that is easier called save calls. Because like in Java, usually there are some complicated if-else that you need to do before doing something that is really meaningful. But in Kotlin, you can just use this question mark dot period, and it means that if B is null, then this whole thing simply returns null. It would not trigger null pointer exception anymore with this case, and it can be chained. So if any one of it is null, the final result would be null. And yeah, this is the basic things that I would like to cover today. And one thing that and there is this exclamation mark operator. If you want to cast a if you want to cast a non-null type, if you want to cast a value to a non-null type, you can cast it via this double exclamation, and an exception will be thrown if B is actually null. So if you want null pointer exception, you can still have it, but you have to ask for it explicitly. And there is also some safe cast. Yeah, I think that's all we need for today. So let's continue on where we have left last time. If you have any question, just ask it in a stream, and I can answer it for you. Okay. So let's improve this one. So how can we improve this one here? Because we are making useless checks for this case. I think we can actually merge these checks into one. So like for example, let's check this one and this one and this one, and when we are doing this, whenever we we find a violation, we can give it one chance, and like we can either, because if this violation happens here, we can either remove it, remove the later one, or remove the let me think about it. I think remove the later one is not always the best option that you can have, because I think there are test cases for this kind of violations. So Yeah. It is possible that the violation, if you remove, you can either remove the first one or remove the later one too. Like, let's have some examples. Like, let's take first this one too, for example. Because when we're comparing 1 and 3, we find that this is valid, it is strictly increasing. Then we continue on and check 3 and 2. Because 3 and 2 is violating, so we can do either remove 3 and make it increasing, or it is also possible that when we remove the second one, it become later one, it become increasing. So yeah, in this case, these two both works. So basically what we're going to do is to first check this pair and the next pair, and whenever there is a violation, we check if either removing this one, this one will work, or removing this one will work. Yeah, I hope that is this simple. Hopefully. So we're going to need to remove all these lousy things. Let's start from the very beginning. Let's just keep this for loop here. For index to be removed and sequence.indices. No, this is not index to be removed. This is the first item to compare, and from 0 to sequence.indices minus 2. If so, let's call this variable failing index and make it something that is never possible. If first item sequence, first item to compare is larger or equal to first item to compare plus 1, then failing index equals to first item to compare. And how do we fix this? We then try to first check if failing index is already exist, which means it's already failing. Then we simply return false, and when everything have passed, return true. So if failing index equals to, and in the next, if we're not changing, well, it actually is giving us a mutable list, so we can do whatever we want if we want to. But I think this is going to be a concurrent modification exception. But yeah, how about this? Let's do this. Failing index equals to first item to compare. Then we will need to check if for failing index is larger than 0, it can't be 0. Then we will try if we can simply cut this one, which will be more optimal. We don't know. So I think let's first try if we can then let's see. Well, this is what I'm thinking. Let's always first swap out the first one that is invalid. If it still fails, then if it still fails, by it still fails, I mean that if the next one that is after the second item is still larger than. So if failing index is larger or equals to +2. Also, we needed first to arrange check here. Sequence dot size, size, and this means this can be fixed by skipping the failing index. So we can directly move first item to compare equals to failing index +2. If this is not possible, we then check if failing index is larger than 0 and if we remove the failing index, which means so it's actually this way. Then we remove the failing index, so it actually moves to and yeah, I think that's it. So else if, and finally if it cannot be fixed, let's return false directly. I'm still not used to removing these semicolons yet. So with this is so much better than the algorithm we have earlier, because there is only one for loop and this is big O n now. So let's take a look what mistakes that we have done in this. Expected type, oh, not in dice, it's size. And what's next? Please, oh, again, this is incorrect. Sequence. and arrow not no get method providing. Okay, this is the same one. So first item to compare cannot be reassigned. Oh, so this is a value here. Oh, this is a value here. Oops. So we need to try to make it a var. Can we make it a variable here? Maybe? Value cannot be reassigned. Oh, I think yes. The answer is yes. No. Okay. Let's check Kotlin loop reassign a var. Okay, let's look at this one. For loops. Okay, I don't think it's talking about anything that I'm expecting. When? Let's look at that next time. So, no, I don't think something that we can. Then we might want to use while for this case then. So, var first item to compare equals 0, while first item to compare is smaller than sequence dot size. Well, that's the workaround I have here, but I'm not sure if this is something that if there is some syntax that can help this to make it easier. Or yeah, of course there are some workarounds that I can do to change this, but I think this is the most simple one. Program exceeds the execution limit because I'm not adding this at all. Index out of bound. Really? Why? Oh, because this should be this. Ah, indent. Looks better. Better? (11) out of 17 paths. So there are some flaws in this algorithm. Let's check. So for this case, 1, 2, 1. We will first check pair 1, 3. And then, because there is no fill index yet, so when the former is larger or equals to the latter, so this happens here, where we will make failing index first item to compare, which in this case is 1. It's 1. And then we're comparing if failing index plus 2, which is this one, is smaller than this one. Oh, it's smaller than sequence.size, which in this case yes. And if sequence failing index this one is smaller than that one, which this is not true, so we become this one. We're removing this one. Then no, we were trying to removing this one, but now we're trying to removing this one. So else if index larger than 0. So oh, actually this is so if this one it's smaller than this one, which is true, and then yeah, we can do it, but yeah, we can continue on, and later we're at, we swap this one to value index plus 1, so we're pointing at this one, this is the caret, and this time we're comparing 2 and 1, it's failing again, so we simply return false. So this is why I'm expecting this, but seems like this is just not happening how it happens. So let's do some debugging here. It might be, so in each iteration, let's print first item to compare and plus done. Let's take a look at, oh, what's happening. Can be called with arguments applied. How about this one? I hope this is going to make it. So 0 done, 2 done, and what happened next? It should return false, but 0 done, first item to compare. Yeah, 0 is done for sure. And in the first iteration, then we move to failing index plus 1, failing index plus 1. This is something that is not correct. We're shifting one step forward, shouldn't we? So even so, because first item to compare to is 2 here, so then it's 3 here, smaller smaller than that size, minus 1. This is still valid, but the size is 4 and it's 3, so it's not going in anymore. 0, 1, 2, 3. So yeah, it should be 1 done here, I think. So because first item to compare is added here, so we're actually updating it to, oh, this is the difference from the for loop and while loop. So yeah, I think this time it should be doing its work now. What's wrong with you again? So this, for this case, yeah, so if there is no item that is in front or behind them, it should actually be true. So it's actually this one, or let's do it this way. Oh, it's not passing. Which one is it not passing? 3, 5, 67, 98, 3. This should be true, but it's returning false. Why? 98, and if the next one is or failing index is the last one, this one. Yeah. Yeah, I think I'm done here. Submit, and it's going to pass the last case. And yeah, happy coding. Finally passed this one. Let's start with the next one later and look and take a look at if let's proceed. Yeah, there's a matrix element sum here, and it seems to be pretty simple here. I've copy pasted the answer I had last time. So after being famous, the codebots are so this is basically so the zero rooms are all haunted. So yeah, this is the example, because everything that is underneath 0 is not suitable to leave. So this is basically, you count from here to down. In every iteration you just add all these items, and only for the items that are non-zero you look at these items and add them. This seems to be pretty simple, but let's do it tomorrow because we're running out of time today. So that's all for today. If you have anything that you want to learn about, just let me know in the comments or anywhere in the either Facebook or YouTube. So that's all for today. See ya, guys.